I sail toward distant shores, indefinite in time. I shall not be afraid to shout the anthem's cry. I shall not be afraid to shout the anthem's cry, declaring to the schools at large the truth and trust inside. Sing a song for science, hail mathematical tools, you students sail the waters, bearing humanity's jewels. Well, hi everybody on this beautiful morning. He's back. It's me, the friendly astronomer, Larry Burrs, with our follow-through lesson, lesson 3 on the solar system scale model. And it gives me a great deal of pleasure to be today outside in the elements, to be able to discover what it truly means to find your place in space. Where are we? That's the real focus of what we're trying to do. And the key through all of this is to better apprehend where we are than to know where we are. And apprehension involves an experience, and we're here today to have that very experience. Are you ready? Kids, grown-ups, everybody who's listening, we're going on a solar system tour scale size. We need to do that because space is big, and we need outdoor zones to be able to truly experience and encounter the happening of a solar system model. Now, the original idea behind this scale model comes from a wonderful astronomy educator named Guy Otwell, who I wish were with us today, but his inspiration is with me. As his model, I'm going to try to engage and execute right now for you. Are you ready? Well, let's do it. The first thing we need to do, and I hope you will want to try this in time too, is to stay safe and secure wherever you make your model. We have our school located in Limestone right now for that purpose, but you may have an immensely beautiful backyard, or you may be near a play or athletic field, a football field, a soccer field, or you may have a park or just some large zone that gives you an opportunity to walk. Because when we do the solar system model as we're going to do it today, believe it or not, take a deep breath because I will, we're going to need approximately 2/3 of a mile, over 1,000 yards, to be able to walk the full solar system model. Of course, you don't have to do the whole thing when you do it, but I really hope you think about what's going on here as you get a better sense of your place in space. Ready, set, here we go. Let's take a walk over to the table of contents. Please follow me. I placed here on a table, and you may want to set up something similar when you do your own model at home or on the road, the materials that we're going to be needing to set up a solar system scale model. Some of these things might already be familiar with you. For example, a meter stick or a yardstick. This is important in scaling. The whole concept of scientific scaling is invaluable in astronomy because things are so big, so far away, so hot, so cold that you have to scale the size of whatever object or phenomena you want to see in astronomy to something that you can get a grip on. It's not like some of the other sciences where you can get the samples right there. So in our case, we're going to take, what is it? Yep, you're right. It's a meter stick in this case, not 36 inches, but 39. That's going to be the standard for our spacecraft. This is going to represent, in our particular case, here's a big number for you, 3,600,000 miles. I say it again, 3,600,000 miles represented, scaled down to 36 inches. If you use a calculator, you can discover that 1 inch is equal to 100,000 miles. If 1 inch is 100,000, 8 inches is 800,000. I bet you already knew that. You're a smart group, I can tell. Maybe you recognize from our inside work in the first 2 lessons with the friendly astronomer our sun ball. Well, it's a bowling ball, but the important part is it's 8 inches across, or in diameter, 8 inches. This represents, to scale, 800,000 miles, the true size of the sun. A number that, well, it's the whole idea between reading and viewing. We can read lots of numbers, but when we can view it visually, it means something different. What am I going to do with this? We want to have our sun scale model in a position where we can view it from the other planets to scale. Are you ready to walk the walk with me? Well, here I go. What a coincidence. There happens to be an appropriate ladder here. And following all the important regulations and rules set and standardized for ladder climbing, I'm going to keep a good grip on the ladder, and I'm climbing forward, not too high. Now, you may not want to use a ladder at your home, and if you're one of the kids that really like this idea, you certainly want supervision and perhaps someone to scout and spot the ladder as you're going up. I'm going to take the ball and to place it in the hollow on top of the ladder so I know it's secure. Obviously, you probably want to work with a smaller ball. If it's a windy day, though, it might blow away. So this is a consideration. And you want to make sure, of course, around the ladder, people are far away, and safety first, and security for everyone. You want to have fun, you want to learn, but you want to be safe at all times. I'm coming back down. How am I doing, everybody? Pretty good. Wonderful. So we've placed our sun ball to scale in a high position that's convenient to see so we can continue our lesson right now. Back to the materials. I'm going to walk over here, and you're probably going to be familiar with some of the things that I show you. And let's do that again. We need our planets. And very tenderly, I'm going to hold them here to scale. Mercury, Venus, Earth, and Mars, hooray. Everyone say hurrah. I can't hear you. That's better. Mercury, Venus, Earth, and Mars, hooray. Very good, hurrah. Mercury, Venus, Earth, and Mars go whirling and twirling amongst the stars, or the sun, and they all go spinning, around and around they go. It's one thing to see the planets to scale, and we've placed our sun ball in the appropriate ladder position. I have another semi-sun ball that gives you an idea of the scale between planets and our star. And this is a 4 to 5 inch ball, not 8 inches. So the planets to scale would be even smaller than what you see here, but I just want to give you an idea that the sun looms huge. We can read about the size of the sun, but it's one thing to view it and have a model. That's why models in science become so important. You can do this for your particular planet. Models to scale. You want pinheads. I've just gone to one of the local stores, and you can do this too if you don't mind waiting in line these days, and you can pick up a bag of pins, colored pins, and you can see I chose black for Mercury. What color? Black. What color is Venus? Yellow, mellow yellow. You got that too. How about Earth? Blue. And Mars? Red, the red planet. There they all are. And they're in sequential order. That means they're lined up the way they should be from the sun. And they're also the current and scaled size too. So what I'm going to do here, I have my terrestrial planets for you more advanced astronomy kids and students out there. Terrestrial planets. I've got a yogurt container here. It's Greek yogurt. And since the word planet comes from the Greek planetes, wasn't that a good choice by your friendly astronomer? I'm going to open this up, and this is going to be a little travel bag for all my planets and objects. And I'm going to curl them around. Bye-bye, planets. And I'm going to put them inside so they're safe. As I learned on this sort of windy day here in Limestone, a gust of wind can spoil your party really quickly. Thankfully, I recovered the planets. I hope you recover them too. I have other planets too. What about those outer planets? Remember them? Jupiter and Saturn are next in line, hooray, hurrah. Jupiter and Saturn are next in line, hooray, hurrah. Jupiter and Saturn are next in line at Uranus and Neptune. 8, that's great. They all go spinning, around and around they go. Well, it's a happy day. I have some nuts here, whether it's a walnut or a chestnut or a beech nut, that are going to stand for our scaled models of Jupiter, giant Jupiter, and Super Saturn, the Lord of the Rings. I even brought for you specialists a ring for Saturn. Nice, huh? Nothing to it. Into the planet tub they go. I'll even put the ring in there. Hope it doesn't leave one on the bathtub. What's next? Uranus and Neptune. Peanut time! Peanut time! Peanut! Hey, Peanut! I've got him here. I'll take 2 peanuts. I say I'll take 2 peanuts. Uranus and Neptune. Now, don't be upset with me. I know one's not turquoise and the other one's not aquamarine, but you can paint them if you want to. That's totally up to you. But the whole idea is that you can get everyday objects to reflect and symbolize your planets. Get in there. Dwarf planets, asteroids, well, time will tell. We need to get on the road, don't we? We're going to be going on our tour right now. I hope you're ready to do this scale size. I'm happy to be with you. I'm ready to begin. Now, I'm going to bring along, and you don't have to do this with your model, but gee, you can have someone hold the planet pin. You can have someone stand where the planet should be, and I don't recommend your little brother or little sister, or even big brother or big sister. They may just walk away, and we don't want that to happen. Well, winter's over, at least in our county, I think. So I brought these old winter stakes, driveway stakes with me that I can put in the ground. You can find maybe a pennant or some kind of other spike to drive in. Maybe put your planet pinhead on a postcard and stick that in the ground. But mind you, if it's windy, things become more difficult. If I had a hammer, I'd hammer in the daytime. So I'm going to hammer away. I'm also going to take the materials here in my planet kit. Bet you don't know what I'm holding here. Maybe you do. It's a piece of welder's glass, strength 14, not 13, not 15, 14. I bought it locally at one of the welder shops, and you can too, or online if you care to go that way. You can hold this in front of your eyes and look safely at the sun. Now mind you, only welder's glass will do this, and I don't want to hear about anybody using any other material that might hurt your eyes. I want to keep everyone safe. Remember, safety first. I'm going to bring it along for a purpose you'll see in just a minute. Are we ready to begin? I can't hear you. Boy, you must be far away. I just can't hear you. Well, we're going to start. Now watch what I'm going to do. I'm going to go over here. It's time to walk the walk. I'm at the origin with the sun still hanging up there. It's a beautiful day here. My, thank you, sun. I'm going to take a deep breath. It's going to be quite a long walk. You better take a deep breath too. Ready? Here we go. Don't you feel better? What's the first planet from the sun that we know of, at least? It looks like that's the one. Yes, yes, I can hear you. Mercury. Mercury. So, what do I know about Mercury? Well, you can find this out too from a book, online. It's 36 million miles away. And we also know from the stick of conscience, our yard meter stick in this case, that's 3,600,000 miles. 36 million. That would be 10 strides, because 10 times 3,000, 3,600,000 is 36 million. I think I'm right. Here we go. I'm going to Mercury. Ready? Deep breath. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Quite a ride on our pacecraft. Mercury. Now I'm looking back here and facing the sun. It's interesting, looks pretty big. Now the great benefit of a scale model is that what you see here is equivalent to what's really going on in outer space. Because the angles that we see subtend, which is a fancy word saying it's the same angle, even though the distance is different, of the target, in this particular case, the sun. Watch what I'm going to do. I have my planet cup. I open the cup. Mercury, where are you? There you are. Now you may do this. You may have someone, your mom, your dad, a grandfather, a grandmother, aunt, uncle, brother, sister to help you. Be careful. Don't drop it. Mercury and the sun. Now this is a very awesome moment. I hope you feel a little awe. Because here's Mercury. Now probably most of you probably your tender ages, rarely if never see the planet Mercury in the sky. Why? Because it's the closest planet to the sun, and it really doesn't travel too far away from the sun in the sky. There are only special times in the year when it becomes visible. And when you do see it, it seems close to the sun. It must be pretty scorchy there. Now, with the scale model, though, we can see Mercury that I'm holding my hand the size of this black pinhead, and there's the sun out there. So there's an immense distance here. Mind you, Mercury's smaller than the Earth, and it's not much larger than our moon. When we look at Mercury, and now we look back at the sun, that's the actual size of the sun from the surface of Mercury, because this is a scale model. Well, enough talk. Back to the walk. Who knows what planet's next? That's right, it's Venus. 7 strides. 1, 2, 3, 4, 5, 6. Wow, quite a ride. Venus, where are you? Carefully I hold you. The planet Venus. I'm 67 million miles away. That's farther than Bangor, Fort Kent, Ashland, Presque Isle, Portland. This is 67 million miles away to scale. Now, if I look back at the sun, good golly, it looks smaller. And here is this broiling, nasty, never spend your summer vacation place, Venus. No moons, no liquid water. It's not a fun place. We know a little more about it than we certainly did years back. And who knows, in those clouds, maybe there's something living. I don't know. Goodbye, Venus. Carefully, I return Venus to its place into the planet cup. You know what's next? 9 strides. Take a deep breath. How long's every stride? 3 to 4 million miles. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. The spacecraft stops. What planet's next? Yep, you guessed it. The Earth, our planet. Home sweet home. And there's the sun. Smaller still. Now the fascinating thing about this moment, how on earth can the sun heat us up? We're really far away from the sun. This represents 93 million miles approximately. It's quite a distance, isn't it? Now the fun part about this, if you look back to the sun on your model, or ours for today, the interesting thing is that the size of the sun to the model is truly the size of the sun in the sky. To prove that, I'm going to take my welder's glass, put it to my eyes, and look up at the sun, look back at the ladder, and lo and behold, the sun on the ladder and the sun high up there. It's the same size. That way you know your model is to scale. Cool? No. Hot. We're not done yet. Maybe it's windy. Maybe you wonder if you've lost a pinhead. Things happen in life and in the solar system. I'm going to hammer with 10 strokes a stake here, so I know the Earth's position. You don't want to be lost in space. Now you've got a reference point. Who knows what planet's next? I'll give you a hint. Red planet. Yep, Mars. 12 strides. Here we go on the spacecraft. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, how do you do? Mars, we are here. I reach into my planet cup. I look for Mars. Where are you? Hiding. This makes an astronomy educator nervous when the planets aren't behaving. Matt Damon, eat your heart out. Mars, the red planet, subject of a ton of tales, target of many spacecraft from the Soviet Union, the United States, Russia to this day, and others will follow. Will you see astronauts on Mars in your lifetime? I don't know. The prospect looks very feasible. Is there life on Mars? I don't know. But we're going to make every effort to discover what's going on the red planet. One more time, Mars. How many moons? Nope, not one. That's right, 2. And maybe from some of your books, you remember they're kind of shaped like potatoes, so butter them up. I'll put Mars back in the planet cup. I think everyone should take a deep breath. I hope I've constructively terrorized you a little bit. We're going into deep space now. This zone that I've covered between my humble person and the sun model represent the terrestrial or inner planets. But we're not done yet. We're going deep. Stand by. Energize. To Jupiter we go. 95 strides. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll try French. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Spanish. 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, I'm tired, 38, 39, 40, 41, 42, 43, 44, 45, 46, beautiful day, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69. What's next? Yep, 70, 71, 72, 73, 74, 75, 76. Let's keep going. March, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90. 1, 2, 3, 4. Hurrah! Huzzah! Jessica! Tonga! Where am I? Whoa! Let's check it out. I'm looking for Jupiter. Feel mighty fine. I stake a claim. Jupiter, where are you? Giant Jupiter. Doesn't look so giant. Come a long way. And we look back at our ladder and our scale sun, old blue ball. Wow, we are in deep space. So one of the important ideas here, not only is the gigantic scale distance here, but boy, the sun looks awful small. And yet Jupiter in the sky from the Earth is mighty bright. It doesn't look like a ball, but it looks like a mighty bright star. So you might ask, and it would be scientific of you to ask,